I'm Anil Kumar, and in this video we are going to understand how to solve height distance applications using trigonometry. So I had a number of requests based on angle of elevation and angle of depression. So we'll actually discuss both these angles also while solving two critical questions. Now these are common questions which you will always come across in the test paper. So these common questions are actually very important application problems, right? So don't take it lightly. They're very serious questions for you, right? So let's begin to understand what is angle of elevation and what is angle of depression to start with. So whenever we are talking about angle of elevation, it really means that you're looking at something upward direction, right? So elevation is looking upwards, correct? And the angle always will be the angle which is made with the horizontal. So it's between the line of sight and the horizontal looking upwards. On the other hand, the angle of depression is basically the angle when you're looking downwards, right? So in that case, the direction is kind of, you're looking from up, let's say from the sky towards downwards, right? But here again, important thing is that the angle is which the line of sight makes with the horizontal. That is a very, very important issue which you should consider. Now let me just mix these two diagrams together. What do you get? You actually get two parallel lines, right? This is, let us say, the sky and this is the ocean, and here is what the situation is. So if you are looking upwards, let's say there is a plane here, right? Let's say there is a plane here, right? Now if you're looking upwards from here, in that case we'll say angle of elevation, right? Let me call it E. It is with the line of sight and the horizontal. But if somebody is watching you from the plane, then in that case we will say that is angle of depression, right? But you will observe here that both these angles are actually equal, right? So both these angles will be equal. Why? Since these are parallel lines, correct? So these are parallel lines. And this line of sight, which is the red line here, is a transverse line which is crossing against the two parallel lines. So what we have here is a Z pattern, right? So this Z pattern, so these are called alternate angles. At times we say alternate interior angles, okay? Now these are always equal. They are always equal. And that is why at times when you have one situation, you can actually find the same angle here and then solve the question, correct? So that is to give you the basic concept. Based on this concept, we have two different questions here. So you can pause the video, copy the questions, solve them, and then look into my suggestions. The first question here is, from a distance of 100 meters, the angle of elevation to the top of a flagpole is 20 degrees. Determine the height of the pole, right? So the situation here is like this. Let's say this is the ground, right? And we have a flagpole here. So we are talking about this position, right? Now the question is that from a distance of 100 meters, the angle of elevation to the top of the flagpole is 20. So let me just join the top with a line. We'll call this as line of sight, correct? And what we are given here is the angle of elevation. And this angle of elevation is this angle which the line of sight makes with the horizontal, that is 20 degrees. That is given to us. And we are also given one more thing, and that is distance, the horizontal distance. From a distance of 100 meters, the angle of elevation to the top of the flagpole is 20 degrees, right? So from a distance, I should have written base, right? From a distance base of the pole, right? Sometimes to make it clear, so we are saying it is from the base of the pole, right? So that is the distance, 100 meters. What you need to find is the height, h. That is your question, right? So that is a height and distance question, as we have mentioned right on the top here. It is height and distance application. You need to find the opposite height side of a right triangle. This is a right triangle, perfect. So tan ratios are the ones to be used. So we'll say tan of 20 degrees is equals to height over adjacent side, which is 100. So height over, you get an idea, right? Now these are ratios. You could cross multiply, find the answer. So we get height h equals to 100 times tan 20 degrees. You get an idea, right? At this stage, you have to use a calculator and say 100 times tan of 20 degrees is equals to 36.39. Okay, so we get height equals to 36.39. Let's round it to one decimal place and we say 36.4. The units are meters. You get an idea. So that is how you need to solve such questions. I hope the concept of height, distance, angle of elevation, tan all comes together to you, right? Now let's look into the next question, which is similar but from a different angle, and this time we'll discuss depression, okay? Angle of depression. The question here is, an airplane is flying at an altitude of 600 meters. When the angle of depression of the coastline from the plane is 15 degrees, how much farther does the airplane have to fly before it crosses the coastline? Okay, so in this case we are looking from the top, right? So that is a coastline. Now let me sketch the similar diagram. So like this, do you get the idea, right? In this case we have an airplane there on the top, and the angle of depression is given to us along with the height of the plane, right? So we are also given the height this time. So earlier we had to find height, now we know the height is 600 or 1000 meters, right? That is the height of the plane, right? So that is the height of our plane. Okay. Angle of depression is given to you. How much is that? 15 degrees. Remember, it is always with the horizontal, correct? Now since we know these two are parallel lines, so this angle is also 15 degrees. You get an idea. So that is why I said that Z pattern is kind of important to understand. Now what do we need to find? We need to find how much farther does the airplane have to fly before it crosses the coastline. So let's say this much farther, right? So this much farther, horizontal distance. Now that distance is also equal to this distance. Is that okay? So if we find this distance, it is okay because both are same distances, right? Both are exactly same distance. Or you could actually consider this triangle also. Either way, it's the same thing. It becomes a rectangle, correct? So now let's this time solve for the distance, right? So how are you going to do it? You can actually pause the video, answer the question, and then look into my suggestions. So what I will say, I'll say let the distance be d. In that case, tan of 15 degrees is equals to height of 6000 meters, right? Divided by distance d, and distance should be equals to 6000 divided by tan of 15 degrees in meters, correct? So we'll use calculator once again and say 6000 divided by tan of 15 degrees equals to, let's write it down, 22392.3. Okay, so this is a huge number. So we'll write this many meters. We can divide by 1000 to write kilometers. Okay, if I divide so many meters, or I could say 22.4 kilometers. Rest, right? So I'm rounding it to kilometers, right? So 3 places, 1, 2, 3. Okay. So 22.39, I'm rounding it to 22.4 kilometers approximately, right? But the idea here is to understand how to use angle of elevation, angle of depression, height, distance applications, tan theta. How do they all come together? I hope this point is absolutely clear from these two examples. And take few more. I'm providing you with a link which will take you to few more examples like this. You should now solve questions from your book. That should help. Thank you and all the best.